Hello and welcome to Unit 3, Expressions and Equations. Today, students will be able to evaluate expressions by combining like terms. Students will be able to identify the different parts of expressions, and this is important for future math problems, like using mental math or solving equations. So we're going to look at some properties first. First one is commutative property. That's commutative, like commuting back and forth to work, where the order doesn't matter. So we have the commutative property of addition. So a plus b equals b plus a. That means 1 plus 2 should equal 2 plus 1. Let's see if that actually works. 1 plus 2 is 3. 2 plus 1 is 3. That checks out. We can switch the order for addition. What about multiplication? 3 times 5 is 15. 5 times 3 is also 15. And yeah, that checks out. For adding and multiplying, we can switch the order. So the commutative property means we switch the order. Switch the order. So we can add or multiply in any order we want. Addition and multiplication are commutative. What about subtraction? Is that commutative? Well, let's look at this counter example down here. So a counter example is an example that would prove a statement false. So let's look at this counter example for subtraction. Does 10 minus 3 equal 3 minus 10? Well, let's think about that. 10 take away 3, that's going to give me 7. 3, starting with 3 and taking away 10, that's going to give me negative 7. Is positive 7 the same thing as negative 7? No. So this does not work for subtraction. What about division? So let's look at the counter example for division. 10 divided by 5 equals 5 divided by 10. Well, 10 divided by 5 I know is 2, but 5 divided by 10 is 1/2. Does 2 equal 1/2? No. So this does not work for division or subtraction. So we can switch the order if we're adding or multiplying. The next little property that you're learning today is associative property. Associative says that regrouping is okay. You can regroup numbers together using parentheses. So if I look at the associative property of addition, that means I have 2 plus 5 plus 7 should equal 2 plus 5 plus 7. Notice the numbers didn't change, the order didn't change. What will change, though, is the grouping. So I'm going to start by grouping together 2 and 5 on this side. On this side, I'm going to group together 5 and 7. And let's see if that changes anything. 2 plus 5 is 7. Bring down the plus 7. And 7 plus 7 is 14. Let's see if that stays equal. On this side, parentheses first, 5 plus 7 is 12. So this side would say 2 plus 12. And 2 plus 12 is 14. Well, did 14 come out equaling 14? Yeah, it sure did. So that means if everything is adding, then I can group together whatever I want to group together first. How about multiplying? Does that still work? So let's look at these. So in this example, let's look at 2 times 3 times 5. So let's group together 2 times 3 first. 2 times 3 is 6. Bring down the times 5. Let's see if it stays equal. And 6 times 5 is 30. All right, on the other side, I still have the same numbers, 2 times 3 times 5, but this time I'm going to group together the 3 and the 5. So that tells me I would have 2 times 15, and 2 times 15 is 30. All right, so did I end up getting the same number on both sides? I sure did. So the associative property will work for adding and multiplying as well, and this is where we regroup. So as long as it's all adding or all multiplying, then it's okay to multiply or add in any order. Okay, let's look at some counter examples. What about subtraction and division? So let's group over here. 10 minus 2 minus 5. 10 minus 2 is 8. Take away 5 is going to give me 3. All right, let's see what happens on the other side. 2 minus 5. Okay, so this says 10 minus, well, 2 minus 5 is negative 3, and minus a negative means add the opposite, and so that would end up saying 10 plus 3, which is 13. Did 3 come out equal to 13? No. So this does not come out equal if they are all subtraction. What about division? Let's divide 50 divided by 10 divided by 2. If I start with 50 divided by 10, then I get 5. And 5 divided by 2 is going to give me 2.5, or 2.5. Okay, let's see what happens on the other side. On the other side, I still have 50 divided by 10 divided by 2, but this time I'm going to group together 10 divided by 2. So this would say 50 divided by, well, 10 divided by 2 is 5. And 50 divided by 5 is 10. Did 2.5 come out equaling 10? No, it sure didn't. So we're going to cross out all these equal signs. It does not work for division, but the associative property will work for adding and multiplying. So let's look down here. Commutative or associative, identify each property. Notice in this one, 7 plus 4 equals 4 plus 7. What happened? Well, they switched the order, so that's commutative. Commutative. So I'm just going to write it like that, commutative. Switch the order. In this one, I see parentheses. The order did not change. The only thing that changed was the regrouping, and so that one's associative. That's the associative property. All right, over here, number 3, 5 times 9 equals 9 times 5. Order has switched, and so that's commutative. And here I see 4 plus 2 plus 3 equals 2 plus 4 plus 3. They tried to trick us with parentheses, but what really switched was the order. 4 and then 2 and then 2 and then 4, and so what really changed, that's the commutative property. They switched order. All right, so what we are doing mostly today, though, is working with terms and expressions. And so variable is our first vocabulary word. It's a letter that stands in for a number. So, for example, if I don't know a number, but I know if I add 3 to it, it equals 5, I could write it like that, like we would have written it in kindergarten. But in 7th and 8th grade, we use variables. And so instead of open box, I'm going to use an x plus 3 equals 5. And so a variable is that letter that takes the place of a number we don't know. A numerical expression is a mathematical phrase that uses numbers and operations. So this is just numbers. So for example, 1 plus 2 equals 3. That would be a numerical expression. Algebraic expression uses variables, numbers, and symbols. Variables, numbers, and symbols, so that would be something like a minus 5 equals 10. Because there's a letter, a number, and some operations and stuff, that's an algebraic expression. Next up is a term. A term is a part of an algebraic expression, either a number or the product of a number and variables. Terms are separated by addition and subtraction symbols. All right, so let's look down here, identify the number of terms. So here's what it means. Here's a term. Because I see a subtraction symbol, this is another term. There's adding, there's another term. There's subtracting, there's another term. So how many terms are in this? There's 4. What are the terms? Well, they're 12a, b, 3c, and 6. Next up are coefficients. Coefficients is a number multiplied by a variable. So in 3x, that really means 3 times x, and so this 3 is a coefficient. In 2b, the 2 would be a coefficient. In negative 5y, the negative 5 would be a coefficient. Because it's attached to a letter, it's multiplied by that letter. The other word here is a constant, the number that has no variable. So if I had 2x plus 1, the 1 doesn't have a letter, and so that would be a constant. If I had 5y minus 3, the negative 3 would be a constant because that does not have a letter. It is not being multiplied by anything. So in this little example here, there are 4 terms. What are the terms? Well, I underlined them. What are the coefficients? Well, we have 12 is attached to an A. We have negative 1 is in front of this B. We don't see ones, but they're there. And we have 3 is in front of the C. What are the constants? The only constant, the only number here without a letter is the negative 6. All right, let's try that again with this one. Number 2. Let's look at how many terms. So I'm going to underline because they're separated by adding and subtracting symbols. So I underline everything that's like chunked apart. So this one has 1, 2, 3, 4, 5 terms. 5 terms. What are they? Well, they're underlined. What are the coefficients? So I see a letter. The number in front is a 7. I see a letter. The number in front is a negative 3. I see letters. The number in front is a 4. I see a letter. The number in front we don't see is a 1. What are the constants? Are there any numbers here without a letter? Oh, yep, there's one right there. So the constant here would be a 5. All right, combine the following like terms. So what this means is we can add or subtract the coefficients of the same variable. So here, because they have the same letter, so I'm going to write in here same letter, but it also means same exponent, same letter, then I can combine the numbers together. So 2x plus 4x would equal 6x. 7x minus an x would equal 6x because there's a 1 in front of this that we don't see. 2x minus 5x is going to give me negative 3x. 2x minus 5x plus 1x. So let's see, 2 minus 5 is negative 3. Add 1 back, and we'd get negative 2. Negative 2 x's. All right, over here, number 7, 12n minus 2n. So far I'm at 10n minus 9 more. So that would be, again, 10n minus 9n. And so that really gives me 1n. And we don't need to write a 1 in front. 3n plus 8n is going to be 11n's minus 4n's, and 11 minus 4 means I'm going to have 7n's. 3c plus 8c is 11c plus 2n. Oh, I can't combine those together because they're not the same letter. Number 10, 5 plus negative 3 I know is negative 2, plus 2. 12 plus negative 2, I'll combine those together. Remember, commutative means I can combine in any order I want. 12 plus negative 2 is going to be 10. And negative 2 plus 10 is going to be 8. Notice nothing on there has a letter. Those are all constants, so they're also seen as like terms. This has a back, so let's turn to the back and go over here. All right, so combine the following like terms. Remember, that means they have to have the same letter. Same letter, same exponent. All right, so we have 3x, 5y, and 4x. I see 3x and 4x have the same letters, so I can combine those. 3x plus 4x would be 7x, and then I just bring down the plus 5y, because that's the only one with y. So that's where we would stay. That would be completely simplified. How about here? 4a, I see an a here. I see some more a's there. So let's combine those. 4a minus 3a is 1a. I also see some constants, 6 and a minus 2. Well, 6 minus 2 is positive 4. So that's what it would look like, completely simplified. Number 13, I see x. Let's look for those. So here's 1x. There's 2 more x's. No more x's. Okay, that's it. So 1x plus 2x, there's 3x. My next letter is a y. So I'm going to double underline this time. There's 3 y's there. Plus 4 y's there. Any other y's? Nope. So 3y and 4y is going to be 7y. And then I have another letter, minus 2z plus 7z. Minus 2 plus 7 is going to be a positive 5z. And I don't have any other letters, and I can't combine those because they're not the same letter. On to number 14. There's 5y. And 3y. Oh, there's another 1y. Any more y's? Nope. 5 and 3 is 8, and 1 more is 9 y's. Next up, we have 4x minus 6x. No other x's, and so I'd get negative 2x. All right. Let's look at a couple more. Let's just look at these really fast. Okay, so this one I have 6d. There's a d. There's a d. No more d's. 6 and 7 makes 13 D's. Next up, I have a constant. Minus 5. I have a minus 11. That one's got a letter. Here we go, plus 7. Minus 5, minus 11, that's going to be minus 16. Negative 16 plus 7. Negative 16 plus 7. I have more negatives. And how many more negatives do I have? I have 9. So that would be it. And then this one has a y. Nothing else has a y, so I'm just going to copy this down so that I list it there. There we go. All right, c minus 4c is going to be negative 3c. Negative 3 plus 2 is negative 1. And no other, so that's negative 1c. Up next, I've got a constant, 8. And that's got a letter, negative 12. That's got a letter. So here we go. 8 minus 12 is negative 4. And 5w minus 1w is going to be 4w. Okay, there we go. So that's the main idea here. Collect terms with the same letter or variable, and then with no letter or variable. In other words, a constant. So collect all of the coefficients, add them all up, and collect all the constants. Let me know if you have questions and try your exit ticket today. Yay, math!